Hey students, so I had a discussion, and in one of the videos, in the visualization video for the lecture class, I discussed, I mentioned very briefly pie charts and said don't make them. So I wanted to expand a little bit on why pie charts are actually rather strongly disliked by statisticians. Uh, so and this is getting a little bit into visualization theory. So, long story short, don't use pie charts. But there's actually a lot of reasons why, and those reasonings are enlightening on what actually makes a good visualization. Now, you probably see on the screen, like just for a little bit of fun, uh, some fun pie chart memes. So, just getting to the point of how ridiculous pie charts are. But let's get to the basics. So I didn't even talk at all about how to make pie charts in R. Let's suppose for a second that you are going to ignore my advice and make some pie charts. Well, what would you do? So I'm going to start up an R session. I have a vector for the possible labels of the groups in the pie chart, and I have also counts for those groups. So let's go ahead and run this stuff. We'll make these labels. So the R function for creating pie charts is the pie function, not shocking. And you give it the values and you give it the labels of the groups, and you can also optionally give it some colors. It can come up with some default colors, but the default colors are really pastelly and kind of hard to understand. And this is the resulting chart. So now you've got yourself a pie chart. And let's just leave it at that before I go any further. So, so let's get into the reasons why pie charts are bad. In visualization theory, there's this notion of what first off, what makes a good visualization? I would say that a visualization is effective when it's able to accurately portray the information in a data set via visual means in as effective and easy a way as possible, so that the viewer, upon seeing the visualization, very quickly has an accurate impression of what's in the data set and the relationships amongst the variables in the data set and even the values of the variables in the data set. It would be awesome if the viewer of the visualization could even read the visualization and infer what the values of the data in the data set are. So that is what I would consider a good visualization. All right, I'm done with this little slideshow. Oopsies. I turned myself off. Now it's going to do that. All right. So getting back to this. So we have these criterion for what makes a good visualization. And when understanding visualizations, you should understand that visualizations communicate information via visual channels. So visual and channels include things such as length, color, hue, saturation. You have position, the X and Y position. You have area. You have angle in the case of pie charts. You have all these visual channels through which information gets represented. So a scatter plot, in fact, can be understood as a visualization that uses X position and Y position to communicate the values of the data in the data set. So then a bar chart, which we discussed in the class, is primarily relying on length as a means through which to communicate visual information. And there is a book called The Grammar of Graphics by the name of a guy named Wilkinson. No, that's not what I want. So The Grammar of Graphics. And this book was influential for one of the most popular R packages called ggplot2. Did it not open? Okay, there we go. Oh, it opened up twice. All right, so we'll just go to like the title page. Uh, so Wilkinson's The Grammar of Graphics. This book, one thing I really like about this book that actually was converted into an R package called ggplot2. This is one of the most famous and beloved R packages in existence. Um, it was actually turned into a software implementation, and one of the ideas of this book is that graphics has a grammar. Um, but I feel like the strength of the book and the strength of the ideas of it are really driving home the point, and even turning it into a software implementation that visual that the information and data gets transmitted via visual channels, and in fact, you can in software you can instruct software to communicate data via specific visual channels and tell it what visual channels you want to use. So let's close that. So we can then actually, so the question is, what visual channels should we use? And there is, in fact, humans respond to different visual channels and changes in intensity differently. So we actually have this chart that visualization experts will look at that compares how people interpret changes in intensity of certain phenomena relative to how much of a change in intensity there actually was. So in the case of length, so like visual length, there is actually a one-to-one understanding between differences in visual length, changes in visual in length intensity, so like changes in length, and how much it actually changed. So if it looks like, so if a line doubles in length, then people will perceive a doubling in length. So that change will have been accurately understood by people observing that change in length. Compare that instead to area. Area is sublinear, so that means that if you double area, people will not perceive a doubling of area. They'll perceive something less than a doubling of area. Yeah, we have these other areas too, and if you go to other books, you might see more visual channels being compared in this way. And bar plots rely primarily, I think actually position also, things that are twice as far away look like they're twice as far away. So position is also a good area, is a good visual channel through which to communicate information. But this plot suggests that area is a weaker means through which to communicate information. Volume, as in the volume of a 3D object, is actually is even weaker than area for communicating visual information, or in how people perceive changes in intensity. And bar plots are relying on length, which according to this chart is a very good way to communicate information, whereas pie charts in comparison are relying primarily on either area or angle. And both area and angle, like area is, according to this, not a great way to communicate information, and angle is even worse. So via that analysis, we would suggest that you should not be using a pie chart, because it's using weak channels through which to communicate information. So it will be incorrectly perceived by viewers. And in addition to that, just using a pie chart is not that easy. Let's go back to this R pie chart. So looking at this R pie chart, how can we compare the values between A, B, C, and D? In this case, it's actually not that hard because there's a big difference between D and B and a big difference between C and B. But if we were more subtle in the values in the chart. So maybe we could, uh, so let's go to pi and change this so that um, if we, so that it's instead, let's say 20, 21, 22, and 26. Okay, it is much harder to decide which is larger than which. Like how much larger it. I guess we get to see that D is more than a quarter of the area, but which is harder, A or which is larger, A or B? Like you can figure out that it's A, but it's not that easy. Especially like B and C are really hard to differentiate in this chart. So comparison of values is difficult in a pie chart. Also, you have this strong dependence on how the data in the chart is arranged. Like you rearrange the chart, you rearrange these slices, and you seem to get a completely different chart. And that's something that's going against pie charts. Let's see, what's something else I wanted to say. Um, oh yeah, if you add like a ton of slices to a pie chart, well, first off, let's see what happens if we were to just add one slice. If we add only one slice, then the entire chart changes. So let's go back. No, we've already got that. So here I have amongst these potential data sets, um, I have an additional pie chart where I added another data observation, and we do that, and the entire chart changes everything about it, and all the slices have changed in their areas. Their relative areas are still the same, but it's not very easy for humans to figure out relative area. And the fact that you have a slice going from being a significant part of the chart to now looking like a minor part of the chart, like that's unfortunate. It makes it more difficult to actually compare the values. Like, well, for starters, you can't even read off at all what the actual original data was. It's impossible because it's not written down. And you can say, well, we could write it down, but no, 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 no. Visualization methods, you should not necessarily require that you write down the data values. I mean, it's good to have like some sort of key, but uh, like having the key is good, but at the same time, though, um, that's not really what you should have happen. If you have to have a key in order for you to be able to understand it, then you have a problem. Um, so like for example, bar plots. It's possible to write bar plots that or create bar plots that have like a very minimal key. So um, if we were to increase to increase this problem of difficult to read pie charts, we could do like pi 1 through 10, and like that's just about impossible to read. Like it's really hard to tell what's going on in this picture, and you add more slices and this thing becomes even more intractable. So oh, and just for a real monstrosity, um, so this is a 3D. Oh, I need to load in. I think I need to load in this library. Yeah, I do. Um, this is something that you can do in Excel. Make a 3D pie chart. Visualization experts call this a duck. This is a duck. And if you want to know why they call it a duck, you can read a book by a man who's actually very famous in visualization theory. His name is Edward Tufte. So, and this is basic. These are basically Tufte's words on pie charts. Tables are clearly the best way to show exact numerical values, although the entries can be arranged in semi-graphical form. Tables are preferable to graphics for many small data sets. A table is nearly always better than a dumb pie chart. The only worse design than a pie chart is several of them, for then the viewer is asked to compare quantities located in spatial disarray, both within and between pies. And in this heavily encoded example, he's referring to this example here, where you've got several pie charts all overlaid in the Middle East around Israel and Palestine. Um, Uh, so, as in this heavily encoded array from an atlas, given their low data density and failure to order numbers along a visual dimension, pie charts should never be used. Um, let's see if I can find Tufty's duck. So basically, in visualization, a duck is a visualization method where basically the decoration dominates. The decoration overrides its functionality. And in the case of a 3D pie chart, you are throwing on top of the difficulties with a pie chart. You're throwing in visual perception. Um, you're throwing in spatial perception and depth. Depth is an additional complication, and you're throwing in volume. And as I mentioned before, volume is somewhat difficult to parse visually. Where is the duck? Where is the duck? So the duck, the duck, the duck. This is a good book to check out, by the way. It's very readable. Yeah, we're getting near the duck. This is a duck. This is a building, but it's a duck. It's awful. So, and it's actually coming. So it's all right. So the self-promoting graphics, the duck, the graphics that are just like they are just so into themselves that they got to be 3D so that they can look all fancy. Like the thing is, you can't read this thing. This thing is completely useless. All it is, you add an embellishment to the graphic, and that embellishment takes over the graphic, and now it is the graphic. Like this is no longer a pie chart. This isn't even a visualization anymore. It's just a 3D thing. It's a duck. Don't make ducks. All right, now that we've talked enough about ducks. So anyway, some more about that. I think that's pretty much it when it comes to why pie charts are terrible. And compare that instead to probably the gold standard of visualization, which is the bar chart. Bar charts in comparison. Let's create bar charts for these data sets that I was showing you. So the R function for creating bar charts is oops. Oops. So the R function for creating bar charts is bar. Oh, no, not bar. Bar plot. Okay. I don't know what it's complaining about. So I know that this will work. There we go. So here's a bar plot. Bar plots rely primarily on length to communicate information, and as I mentioned a second ago, length is a strong visual channel through which to compare information. Because whereas it's really hard to compare the slices in a pie chart, with bar charts you can just do a straight comparison, and you can rearrange these bars, and the bar chart is essentially the same, and you can still make the exact same comparisons. And if you were to add another bar to the bar plot may in fact not change at all. Or if it does, I mean, it is in fact possible for the bar plot to change, but it probably won't change by much. So it did change, but you can still make the same comparisons. This key on the left-hand side, it's still good. This key on the left-hand side, you can still use this key to almost read off the data values. There's another concept in visualization that Tufty pioneered, and he pioneered this idea of information density, or he likes to think of it, he also calls it ink to data ratio, where how much information do you get with so much ink? You can actually make bar plots with very high ink to data ratio. I'll very quickly draw them because I can't think of how you would do it in R. But basically, a bar plot could be exactly the same if you were to use straight lines. It would have the exact same information. You'd have almost no ink. So you get lots of data, lots of information with almost no ink. Whereas pie charts will have exactly the same amount of ink, no matter what. So their ink to data ratio is often all over the place, but it's generally really poor. So you always have to draw the exact same circle, and you're just going to draw more lines in that circle, but it just seems like a waste of space for the most part. Whereas bar plots can you can basically convey the exact same information with almost no ink, with very little ink. So the width of these bars is pure embellishment. You don't actually need it. So in some ways, I took a visualization class with the computer science department, and they said, if you don't know what visualization to use a bar plot, because bar plots will visualize just about anything and in an effective manner. You can add as many groups as you want to this bar plot. You can rearrange the bars, and the bar plot will do the same thing. There's one reason why I think people might still look to pie charts, and they get hung up on showing parts of a whole. So they'll say this is the budget. The budget has so much money, and they want to convey how much of the budget is going to certain areas. The thing, though, is it's not entirely for one thing, bar plots can still convey the same information. You can tell people that this all adds up to the budget. And it seems to be just as effective as having a pie. So, I mean, you can basically just say this is part of a whole, and then go along with the bar plot. It doesn't like force it, but it's still showing the same information. So it's questionable what people are even getting from requiring that you show that something is part of a whole. Like if you put all those bars, if you convert it into a bar plot and then put all those bars together, you can still say this is all part of the same thing. You just have separate parts of the budget. And the cost that you pay for this luxury, honestly, of showing parts of a whole seems to be too high. So, because in order to convey parts of a whole, you end up with an objectively weak visualization that is just not nearly as good as a bar plot. And in fact, like some people said, well, pie charts are easy. And like I think even Wilkinson was saying that pie charts are a little too unfairly maligned by statisticians, since like he says, a pie chart is so simple it literally is what it is. It's a pie, right? And then he follows that up by saying managers love pie charts way too much. The thing is, bar plots are just as simple as pie charts, and give you the same and are just as effective. So, long story short, don't make pie charts. And while you're at it, if you're at all curious about what it takes to make good visualizations, Tufte's book, let me pull that book up again. So it's called The Visual Display of Quantitative Information. And I would suggest that you read it. Like, these are considered classic books in both statistics and not just in visualization, but in statistics overall. In fact, if you look at my lecture notes, they have this certain placement style that was first created, like this page formatting style. Tufte was the one who created that page formatting style, and people absolutely love it. The giant margins, the margin notes, putting stuff in the margins. Tufte was the first one to do that, and it looks really good, at least in my opinion and in many others' opinion. And it is in fact useful. So he was an expert in this subject, and his book is quite pleasant. It's got this Zen quality to it. It's not a heavily technical book, and reading that book will help make you make very good visualizations. So That's all I wanted to say. Don't make bar plots, but not just don't make bar plots. Think about why you shouldn't make bar plots. And using that criteria, think about what plots you should be making and whether you are making good looking plots. Also, don't make ducks. Like you can also make bar plot ducks. Those 3D bar plots that you can make in Excel, just leave it all alone, all right? If you're doing 3D, stop. There are some times where you can make 3D visualizations and they're actually okay. But the 3D bar plots, anything where you're putting any sort of depth on when you don't need it, if you're putting on decorations in your graphics when you don't actually need the decorations, then you're doing something bad. So, don't make ducks. Don't make duck plots. All right, that's it. Thanks for listening to my rants, and see you later.